Hello students, welcome back to my channel. So in this class we will discuss these two problems. So already in last class we learnt how to balance the skeletal equation. Okay, so here these two types of problems will be come to the exam, we can guess. Okay, so here in this question what is given? First we have to write the data. Calculate the volume, mass and number of molecules of hydrogen liberated when 460 grams of sodium reacts with excess of water at a STP. So here by the using of this one we have to write the first chemical equation. So here what we have to find out? Volume, mass, number of molecules of hydrogen liberated when 460 grams of sodium reacts with excess of water. So sodium reacts with excess of water to liberate which gas? Hydrogen gas. And here sodium hydroxide will be formed. This is the chemical equation. So we have to balance this equation. Here 2, here 1, 3 hydrogens. So we better to take here 2 moles. So 2 sodiums, here 2 sodiums. Here 2, 4 hydrogens, here we should take 2 moles. So it is a balanced equation. How to balance the chemical equation? If you want to learn, so please watch the previous video. Okay, so here according to this equation, how much mass of sodium gives how much mass of hydrogen gas, and how much volume of hydrogen gas, and how many number of molecules of hydrogen gas are given. So we will see. So that one, here sodium atomic mass is 23. So here how many sodiums are given? 2. So 2 into 23. So that is 46. If we take the atomic mass in the grams, that is 46 grams. Next hydrogen gas mass what? Here 2 grams. Hydrogen atomic mass is 1. So 2 into 1, 2. So 2 grams. Okay, so like that, here 46 grams of sodium has given 2 grams of H2. Okay, and here at STP, here it occupies how much volume? 22.4 liters. Okay, 1 mole of H2. Here how many moles of H2 gas is given? 1 mole. So 1 mole of any gas occupies 22.4 liters at STP. STP means standard temperature and pressure. That is 273.15 Kelvin and 1 atmosphere pressure. Okay, next 46 grams of sodium gives that is how many number of H2 molecules? That is Avogadro number of H2 molecules, Na molecules. Understand? So here what is the relation? 46 grams of sodium has given 2 grams of H2, and 46 grams of sodium has given 22.4 liters of H2 gas, and 46 grams of sodium has given Na number of molecules of H2 gas. So that is Na means Avogadro number, its value is 6.023 into 10 power 23. So now we will find out the volume, mass and the number of molecules of hydrogen gas liberated when 460 grams of sodium. So here 460 grams of sodium. Then 460 grams of sodium gives how much mass, how much volume and how many number of molecules. We have to find out these three. So first one is a mass of H2 gas. Okay, here we know that is according to this equation 46 grams of sodium has given how many grams of hydrogen gas? 2 grams of hydrogen gas. Then in the question what is given? 460 grams of sodium. 460 grams of sodium is given how much amount of hydrogen gas. Okay, we have to find out. For example, this is let x1. So that is x1 is equal to cross multiplication 460 into 2 is divided by 46. So 46 ones are 46 tens are. So that is here we got 20 grams. 20 grams of hydrogen gas. So next second one, volume. Volume of H2 gas. Volume of H2 gas. Okay, here we know that how much 46 grams of 46 grams of sodium is given 22.4 liters. 4 liters of H2. Then 460 grams of sodium is given how much volume of hydrogen gas. So just let this is X2. So then here we will get, that is X2 is equal to cross multiplication 460 into 22.4 liters is divided by 46. So 46 ones are 46 tens are. So that is we will get 224 liters of H2 gas. H2 gas. Okay, next third kind, number of molecules. Number of molecules. Number of molecules of H2. Number of molecules of H2. So we know that is as per equation 46 grams of H2 gives here Avogadro number of molecules of H2. So 6.023 into 10 power 23 molecules of H2. So then 460 grams of H2 gives how many number of molecules of H2. So here let X3. So then X3 is equal to cross multiplication 460 into 6.023 into 10 power 23 is divided by 46. 46 ones are 46 tens are. So here 10 power 23 will become 10 power 24. So answer is 6.023 into 10 power 24 molecules of H2. Okay, this is the solution of this problem. Understand? Okay, now we will see here if limiting reagent concept is involved in this problem, how to solve. Okay, so very important it is. Compared to this one, it is somewhat different. Okay, so concentrate, calculate the volume and number of molecules of CO2 liberated at STP if 50 grams of calcium carbonate 50 grams of calcium carbonate is treated with a dilute hydrochloric acid, HCl, which contains 7.3 grams dissolved in HCl gas. So here calcium carbonate is reacting with HCl to form a calcium carbonate. Next here in this H2O is formed. Next CO2 gas is liberated. So we have to find out volume and number of molecules of CO2 gas liberated when 50 grams of calcium carbonate. How much here? 50 grams of calcium carbonate is reacting with 7.3 grams of HCl. Okay, clear? So here only relation between here, we no need to consider this one CaCl2 and H2O. So just we should consider CO2. So here what is the mass of this one? 44 grams. Carbon atomic mass is 12, oxygen is 16. 2 16 is 32 plus 12, 44 grams. Understand? Okay, now according to this equation, what is the mass of this one? Calcium carbonate, calcium atomic mass is, atomic number is 20, atomic mass is 40, carbon is 12 and oxygen is 16, 16 3 is 48. So here 100 grams. So that is as per equation 100 grams of calcium carbonate reacts with here HCl molecular weight is 1 plus hydrogen is 1, chlorine is 35.5. So that is 36.5 grams. Okay, so then here how much 44 grams of CO2 will be found. Sorry. Understand? CO2 will be found. So 100 grams of calcium carbonate reacts with 36.5 grams of HCl to form 44 grams of CO2. At STP, here same 22.4 liters. Here how many moles of CO2 gas is liberated? 1 mole. So that is 22.4 liters of volume. And it contains how many number of molecules of CO2? 6.023 into 10 power 23 molecules. 10 power 23 molecules. Understand? Okay, here 100 grams of calcium carbonate is reacted with 36.5 grams of HCl. Okay, then 44 grams of CO2 is released. So if 50 grams of calcium carbonate is reacting with 7.3 grams of HCl, then how much amount of CO2 gas is formed? We have to find out. So here 100 means here 50. So 50 by 100, number of moles how many? Here 50 by 100, that is half mole. Then here 7.3 by 36.5, how many moles here? Tell me. Here that is here 50 number of moles given weight by gram molecular weight. So 50 by 100. So that is 0.5 mole. Okay, here 7.3 by, here is this balanced? No. So we have to take 2 moles. I forgot, sorry. 2 moles of HCl. 2 moles of HCl. So then here you should take here 2 into 36.5. So that is 7.3 by 73. So then here we got what is that? 0.1 mole. 0.1 mole. Understand? Okay, here 0.5 mole, here 0.1 mole. Here 100, for 100 73 grams. Here what is that? What is this here? This is 73 grams. Okay, for 100 grams of calcium carbonate, how much amount of HCl is required? 73 grams of required. 73 grams of HCl is required. So then 44 grams of CO2 is formed. Okay, if 50 grams means it is half of the this one 100. Okay, then we have to make this also half na. So then we here 36.5 grams of HCl is required. But what is given? 7.3 grams of HCl is given. So means there is no required amount of substance is given to occur the chemical reaction completely. So that is called limiting reagent. Limiting reagent means the substance which is not sufficient to occur the chemical reaction 100%. Okay, this is called limiting reagent or limiting agent or limiting reactant. Limiting reactant. So here what is the limiting reagent? HCl is the limiting reagent. Understand? So this is a limiting reagent. This is a limiting reagent. Limiting reagent. Understand? So here we have to compare only limiting reactant or limiting reagent and carbon dioxide gas only. That's it. Okay, here how much amount of CO2 gas is liberated? How much amount of CO2 gas is liberated when we take 7.3 grams of HCl? That's it. So this is the relation. Okay, so here actually as per equation 73 grams of HCl forms 44 grams of CO2 gas and gives 22.4 liters volume and gives 6.023 into 10 power 23 molecules of CO2. So then if 7.3 grams of HCl if we take, so what is mass, what is volume and how many number of molecules? We have to find out. We have to find out. Understand? But in this question what are given? Only volume and number of molecules. That's it. So we will discuss that one. So first one is volume of CO2 gas. Volume of CO2 gas. Okay, here as per this one 73 grams of HCl gives how much volume of CO2 gas? 22.4 liters. Then 7.3 grams of HCl gives how much volume of this one? So let X1. So then x1 is equal to cross multiplication 7.3 into 22.4 liters is divided by 73. So then here 73 ones are here 73 0.1. So then here we will get x1 is equal to 2.24 liters of CO2 gas. Understand? So like that take this one, second one, number of molecules of CO2 gas, number of molecules of CO2 gas. Okay, so as per this equation 73 grams of HCl given, that is 6.023 into 10 power 23 molecules of CO2, then 7.3 grams of HCl contains how much? So let x2. So then x2 is equals to 6.023 into 10 power 23 into 7.3 is divided by 73. So now tell me here 73 ones are 73 0.1. Understand? Then here 10 power 23 will become 10 power 22. So that is x2 is equals to 6.023 into 10 power 22 molecules of CO2 gas. So this is the solution of this problem. So here we can guess among these two problems one problem for the annual examination. So maybe they will give a numerical change problem. Okay, no problem. If you understand the concept, if they will give any question related to this concept, you can able to find out the answer. Okay, so regarding these two problems, if you get any doubt, you can mention in the comment section. So I hope you understood this class. Thank you.